Hey there, in this video we're going to talk about compound interest. So what does it mean and what is the formula? So we're going to try to come up with the formula and then do a couple more examples. So suppose $1,000 is invested at 10% interest rate compounded annually. How much money will be in the account after 1 year? And well, how about after 2 years, 3 years, after T years? So after T years is the formula that we're going to want to get to. So let's first start with at the end of 1 year, how much money will you have? Or will there be if it's not your money? So the way we apply interest rate, we do the amount. So we're going to have $1,000 plus the interest earned. So the interest earned is 10%. So 10% means 10 over 100, which is 0.1. So I'm going to do 0.1 times that $1,000. Right, so this is the amount invested, which is also called the principal. And this is the interest earned on that principal. Interest earned on the investment. So in the end, at the end of 1 year, we are going to have 1,000 plus that amount. And actually, I am not going to compute what that is. What we're going to do is notice that we have 1,000 and 1,000 there. We're going to factor it out. So we're going to be left with 1 plus 0.1, which is 1,000 times 1.1, which gives you how much? This would be the 1,100, right? 1,100. So for the second year, so after 2 years, what are we going to do? We're going to repeat this process. But now our initial amount will be the ending amount after 1 year, right? So with 1,100. So for the second year, we're going to have 1,100 plus the interest earned on that amount. So the interest earned is the 10% again, so 0.10 times the amount. Right, so the money that we had at the beginning of year 2 plus the interest earned on that money over the whole year. And so let me do that again, where we're going to factor out the 1,100. So when I factor out, I'm left with 1.1, right? 1 plus 0.10, 0.01 again. So I get this. So what do you notice though? So let me bring up the fact that 1,100, where did 1,100 come from? Notice that 1,100 is up here, is equal to 1,000 times 1.1. So I'm going to change this to say this came from 1,000 times 1.1. And then I have times 1.1 again. So it's really 1,000 times 1.1. 1.1 times 1.1 is 1.1 squared. And if we repeat this process for the third year and fourth year and so on, notice that then after 3 years, if I repeat this process, I'm going to end up with 1,000 times 1.1 cubed. And so what we want to see is that if this is really 1,000 times 1 plus or 0.1 and then cube. So after, and you can continue repeating this process indefinitely. So after T years, our formula would be A of T, or the amount, will be equal to P, the principal, times 1 plus the interest rate. 0.1 was the interest rate, so R to the number of years, so T. And so this is where the compound interest formula comes in. Now this was because we were compounding the amount annually. So this is compounded annually. So annually means once per year. What if we wanted to compound it, say, quarterly? So suppose we want to compound the $1,000 quarterly. So what will that look like? So what I'm doing here is trying to come up with the formula for compounding different amounts throughout the year. So we have it for annually. The amount is P times 1 plus R to the T. And you may already know what the formula for compounding any number of times per year is, but we're trying to come up with it. So if I start with my 1,000 a year, right? So we're going to invest 1,000 and it's going to be compounded quarterly. So what does quarterly mean? This means 4 times per year. So that means that in this $1,000, we're going to accrue interest 4 times in a year. So instead of doing the whole thing after a whole year, we're going to say, how much money do we have after the first quarter? So after the first quarter, you're going to have 1,000, the amount invested, plus the interest earned in that quarter. Well, how am I going to compute the interest earned in that quarter? So the interest earned is 10%, but this is the annual interest rate, right? So this is annual rate. So 4 times a year means that I'm going to have to say 10% divided by 4. So 0.1 divided by 4. So for the first quarter, it's going to be then 0.1 divided by 4 times $1,000. And 0.1 divided by 4 is 0.025. So I'm going to change this. So I'm going to say 1,000 plus 0.025 times 1,000. And we can do what we did above. Factor out the 1,000. So I have 1,000 times 1 plus 0.025. So this is how much money we're going to have at the end of the first quarter. Of course, you can use a calculator and compute what that is, but no, I'm trying to come up with the formula. So what about after the second quarter? For the second quarter, we're going to start with this amount. So I'm going to have, and we can simplify it to say 1,000 times 1.025 once we add those. So for the second quarter, I'm going to have my ending amount from the first quarter, so it's 1,000 plus 1.025 plus the interest earned on this. So the interest earned again now is my second quarter, so it is 0.1 again divided by 4 times the amount. The amount is this. This is my new amount. So 1,000 times 1.025. So notice again, this is common to both of these, so we can factor it out. So I have 1,000 times 1.025 times, I'm left with 1 plus 0.10 over 4 is 0.025 again. So notice that after the second quarter, then I'm left with 1,000 times 1.025 squared. And you can kind of see that it's happening, the same thing is happening as before when we were doing 1 year, 2 years, 3 years, and so on. So after the third quarter, what am I going to get? Can you guess based on the pattern? It's going to be the 1,000 times 1.025 cubed. And so after the fourth quarter, which will be the whole year, so after 1 year, we're going to have 1,000 times 1.025 to the fourth. What about after 2 years? So notice that after 2 years, so in the fifth quarter, we're going to do this all over again, in the sixth quarter, and so on and so forth. So what we end up getting is, so after 2 years, we're going to repeat this process how many more times? 4 more times, right? So it's going to be 1,000 times 1.025 to the 8th. And then after 3 years, to the 12th, and so on. So notice that 8 came from doing 4 times 2. After 3 years, this is going to be 1,000 times 1.025 to the 12th. 12 is 4 times 3. So 4 is because we're compounding it quarterly, and the 3 is the number of years. So in general, the amount at any time t is going to be the principal times 1 plus the interest rate. And if it's compounded on something other than annually, we're going to divide by the number of times compounded in a year. I noticed that the 0.025 here came from doing our 10% annual interest divided by 4 because we were compounding quarterly. So if it was semi-annually, we will divide by 2. And then this whole thing raised to the n times the number of years. So nt. So P is the principal at the original investment. R is the interest rate. N is the number of times you compound in a year. And T is the number of years. So I hope that helps explain a little bit where and how that formula is gotten. So let's try an example. And I have one ready here. So compound interest. So if $2,500 is invested at an interest rate of 3.75 per year, compounded daily. Find the value of the investment after 2 years. So some of the things, as soon as you see compounded interest, or even if this wasn't there, compounded interest part, keywords to look for is like, okay, compounded, and it says compounded daily. So how many times in a year are you going to compound it? So this is going to be 365 times per year, assuming you don't have a leap year. So the formula that we're going to use is A of t is equal to P times 1 plus R over N to the nt. So what do we need to know? So we need to know what P is, the original investment. We need to know what the rate is. In decimal form, we need to know what N is and what T is. And sometimes you may be looking for what A is. So let's see. So the principal is how much are we investing? So we're investing $2,500 at an interest rate of 3.75 per year. So 3.75%, and make sure that you change this to a decimal. So 3.75% means 3.75 divided by 100. So just move the decimal place over to the left too. So 0.0375. And it's the number of times we're compounding in a year. It says compounded daily, so the number of times we're compounding this is 365. And T, do we know for how many years? Yes, 2 years. So T is 2, and A is what we're looking for. So I like to kind of write out all my variables and see what I have. Sometimes we'll be looking for N, sometimes we'll be looking for P, sometimes we might be looking for T. So writing out everything that you have, reading the problem, and stating your variables and their values is helpful for using the formula. So I don't know A. So A is going to be P, so 2,500. I guess I don't need the comma. So 2,500 times 1 plus 0.0375 divided by 365 to the nt. So 365 times 2. So this looks a little bit messy. So 2,500 and what's 0.0375 divided by 365? Let's find that real quick. And when you do it in a calculator, you see that it's not a very nice number. It's even written in scientific notation. So I'm just going to leave it. So I'm going to say 0.0375 divided by 365. And I'm just going to say 365 times 2 is 730. So I'm just going to put this whole thing into our calculator and get the amount right away. So let me bring up our calculator. And so I have, this is the TI-30XS. And so when I put this in, let's see, we're going to do the 2500. So I have 2500 times, so I'm just going to use the parentheses. I'm not going to actually press the times key. And then I'm just going to put in 1 plus, and this is where that fraction comes in, the 0.0375. Let's see if I can move this so we can still see the problem. So, no, I can't, because then I can't see my keys. But we're going to say 0.0375 divided by 364. Your calculator will automatically want to do order of operations, so you don't necessarily have to put parentheses around the 0.0375 divided by 365, because your calculator will do the division first and then do 1 plus that result. If you wanted something like 1 plus 0.0375 and then the whole thing divided by 365, then you definitely need parentheses around the 1 plus 0.0375. Again, because your calculator will automatically want to do order of operations. So in this case, it's fine. Use the caret. So underneath the pi, if you have the TI-30, and that brings up the exponent. And the exponent was 730. So 730. And just press enter. And so there's our amount, 2,694.699996. So we can round that to 0.70 or the whole thing to a dollar amount, 26.95. So that's what we can say. So going back to our problem here, we can say then A is equal to 2,694.70, or we can say 2,695. Always make sure that you state your answer in dollars, so including your units, that's what I'm trying to say. So after 2 years, we will have $2,695. Okay. For this section, for the most part, you'll just be finding A. As we go further into the chapter and we start doing logarithms, we may be trying to look for the time. How long does it take for an investment to reach a certain amount? But in order to solve those types of problems, we need logarithms. So for right now, this is the formula. And think about the compounding time. So if it says semi-annually, that means twice a year. If it says monthly, that means 12 times a year, and so that's what gives you the N. In this case, it was daily, so 365. In the next chapter, we're going to be doing compounded continuously, and so we'll see what that means. All right.